Welcome to our Monte Carlo simulation project. What we're going to do here is simulate the performance of a portfolio over 35 years, incorporating in monthly scheduled payments that you're putting in your investment portfolio. We're going to control, or we're going to model what I call bad times. So obviously, you want to invest a certain amount every month, but some months you won't have the money. Maybe it's Christmas and you're not going to do it. Maybe you're in between jobs and don't have the cash flow to do it. Maybe you're sick and need it for something else. So that's going to be incorporated in the model. And then we're also going to incorporate in the model a base salary, and then we're going to model potential raises as you go through. Now I'm going to do my file with 1,000 lifetimes in the model. You're going to do yours with I'm going to do mine with 100 lifetimes, and you're going to do yours with 1,000 lifetimes. So first step is we get our base file started. Click on our Monte Carlo simulation, pull in the base file. We're just going to go ahead and open it as we have been doing. We're going to enable editing. We're going to enable the macros. Go ahead and click to start, and enter your 800 number. Click OK, and now close. So that has created our Monte Carlo file on the desktop. And as always, we want to go ahead and get it off the desktop and put it onto our jump drive, so that as you save things, they actually get saved to your jump drive. And I'll stress at this point, you also want to remember to go ahead and back up your jump drive periodically, or make sure you have backups of these files. Alright, so I'm going to open my Monte Carlo simulation file, and this is where it comes up. We have our input page. We're going to get some data from a previous project. We're going to create a simulation of monthly returns based on the mean and standard deviation of our portfolio. This is our bad times, which we're going to do to model whether we make a payment or don't make a payment. Bad times 2 is part of that. We're going to model our raises. This first one is going to be a uniform distribution. The second one, we're going to convert a uniform distribution to a triangular distribution. And finally, we're going to calculate what our actual raises are. And then we're going to create our monthly deposits. Right? Raises are annual. And then we're going to take your salary and divide it by 12 to find out what the monthly deposits are. And then we're going to process how much the account increases over time. And finally, we're going to create a probability distribution of final returns, along with, back on our input page, the mean, median, standard deviation, min, max, skewness, and kurtosis of the final values of the portfolio, and the amount that we actually ended up paying in to the portfolio. So that's just a quick overview. We always want to start by kind of organizing things a little bit better. So I'm going to just merge these cells and go ahead and put a line underneath it. I'm going to go ahead and again merge these cells and go ahead and put a line underneath it. For these two cells, I'm going to go ahead and wrap the text. And for the monthly cash here, I'm just going to drag it out so it's not overlapping. Just a reminder once again, if it's colored, highlighted like this, then you're going to need to, it's a graded cell. And again, we put the color again so you know what does get graded. You're welcome to take the coloring off. Alright, so this is a decent start. Maybe organize a few more things here. Go ahead and center our table. Line underneath, so it looks fairly decent. I think another thing I'll do is on this tab, I'm going to, instead of being on the bottom, I want everything centered. Alright, So I'm going to come here, my best performing portfolio, and this is from the historic, this is from project 1. You pick your best performing portfolio. In my case it was the minimum variance portfolio. So I want to bring over the annual volatility and the annual return here. So 10.97% and 18.1%. And I'm just, you can copy and paste, but I'm just going to type them in. So my expected return is 10.47%. Make sure you put this percent symbol in there. And my standard deviation is at 18.1%. So we want to convert that into monthly. To get a monthly return, it's simply equal to my expected return, and we're going to divide by 12. And my standard deviation is going to be equal to my expected standard deviation, and then I'm going to multiply that by the square root of the quantity of 1 divided by 12. So my annual, my monthly standard deviation is basically 5%, and my expected monthly return is about 0.87%. Okay. All right. The base salary that we're going to use, just drag this out a little bit farther so these aren't overlapping. The base salary that we're going to use is going to be $50,000. The investment rate we're going to save at is going to be 5%. That creates an annual yearly cash investment equal to my base salary multiplied by my 5%, $2,500. And then my monthly cash is simply equal to my yearly cash, and we're going to go ahead and divide that by 12. And we'll use this as a starting point. Close that so we don't get any more emails coming through. On average, we're going to assume our raises are going to average about 2%. The minimum raise I'm going to enter here is going to be minus 1%. So you might think, well, how am I going to get a negative raise? There's a couple of different ways. Maybe it's a really tough labor market out there, and your boss says you can keep this job with decreasing your salary, or I can fire you and hire somebody else, in which case you may go ahead and take a pay cut. This minimum raise also models things like you switch jobs because the other job has better benefits but a lower salary. Maybe it's closer to your home, a little less stress. I mean, there's all kinds of things where you may end up with a negative raise. The maximum raise we're going to use is 6%. And this 6% is modeling things like promotions. Okay. So in some cases you may get lots of promotions, in other cases they may be pretty infrequently, but we're going to pick this up in the model. The number of months is simply going to be equal to 12 months per year times a 35-year time horizon on our model. So we're going to model 420 months. Our max minus min is going to be equal to our maximum raise minus our minimum raise. And our expected minus min is going to be equal to our expected mean raise minus the minimum raise. And max minus expected is equal to the max raise minus the expected raise. And we're going to use these to convert a uniform distribution into a triangular distribution. And as I get to that point, I'm going to explain a little bit more on how that works. At this point, we've got basically our input page set up about as far as we need at this point. And we'll come back and finish it as we move through the project. So the next step that we're going to do, and that'll end the video here, is generate our series or simulations of lifetimes and the monthly returns of our portfolio. One thing I'll note is we want to write down our mean and standard deviation And I'm going to take it off percentage and go back to just a straight number. And add a couple more decimal points. And you'll see in a little bit why that's needed. And I'm going to be using 0.087 as the mean, and I'm writing this down 0.0523 as the standard deviation. Alright, so I'm going to come over here to my monthly returns tab, and the first thing I want to do is, again, keep things kind of organized. So I'm going to create a series that goes out. Use the fill command. Fill series rows. I need to start by entering a 1. So we're going to go fill series rows, and we want to go out 100. In my case, 100. In your case, you're going to go out to 1,000. I'm doing 100 lifetimes. You're going to do 1,000 lifetimes. So that just lets us be able to scan out here and find out where the end of our series is. And then if we want to reference a particular lifetime, this represents each simulated lifetime, we can do that. Alright, our next step is to go ahead and populate our different lifetimes with random draws based on the mean and standard deviation from a monthly level of our portfolio. So I'm going to come over here to data and data analysis, and I want the random number generator, and I'm going to ask for 100 random variables. Here's where you'll enter 1,000. So each one of these represents a different lifetime, and then I have 420 months as we calculated before. And then I'm going to be looking for a normal distribution because we're assuming our portfolio returns are distributed normally. The mean is at 0.0087, so that's my average per month. And the standard deviation is 0.0523. And I'm going to click on my output range, and I'm just going to set right here. So I've got my normal distribution, my output range, everything's ready to go, so I'm going to hit OK. Now, this is going to take a second to go ahead and populate, and when you do the 1,000 lifetimes, it may take a little bit longer than that. So you don't want to do this right at the beginning of class, for example. So we take a look. Here's my first lifetime, my first month. I generated a 7.9% return, then a 0.1% return, then a negative 6% return, etc., as we go through. And this just becomes the monthly returns. This is our modeling of the monthly returns that are going to come from our portfolio. You'll notice that these are just numbers. We don't grade the numbers. You'll just go through that process to generate your simulation of each lifetime and how the portfolio performs. So this lifetime we start off with a positive 7. This one we started off with a negative 3. Here we started off with actually 13%. And here we started off with a negative 6. So each one of these lifetimes represents a different potential performance arc of your portfolio. And we're going to use this to then find out what expected values are going to be at the end of the portfolio. Alright, so that finishes our first video for the Monte Carlo simulation project. When we come back, we're going to start working on our bad times. Thank you very much. Bye.